In organic chemistry, we have many different ways of stating the same thing. Let's take the compound butane. It has the molecular formula C4H10. We can draw the structural formula as CH3, CH2, CH2, CH3. If we draw the three-dimensional formula, or the three-dimensional shape, we have 4 carbons that are in a backbone. We typically give a zigzag pattern to this backbone, and we fill in 2 hydrogens here on the end, and give about 109.5 degree bond angles. Now, because each carbon here is tetrahedral, we have to fill in with bunny ears on the top and legs on the bottom, using our wedges and dashed lines to indicate hydrogens coming at us or going behind the plane. So you'll notice though that this takes a while to fill in and really slows you down. So one of the things that we've done in organic chemistry is take and create what we call a hydrogen suppressed line structure. And what we're going to do is we're going to get rid of those carbons and hydrogens and focus only on the other things that are important. Okay? And this can get really confusing, because if we have a hydrogen suppressed line structure, we're going to indicate each carbon as a dot, or the end of a line. So if I have methane, CH4, I simply draw a dot. If I have ethane, CH3, CH3, I draw a straight line. The end of the straight line here tells me that that carbon has 3 hydrogens attached to it, and this carbon has 3 hydrogens attached to it. If we go up one more unit, CH3, CH2, CH3 is propane. We're not going to look like this. This carbon here has 3 hydrogens attached to it. This carbon here has 3 hydrogens attached to it. The carbon here, though, at the apex of these 2 lines only has 2 hydrogens attached to it, which is exactly the same as we see in the structural formula. That means when we get to butane, CH3, CH2, CH2, CH3, we're able to draw a 3-line segment, 4-carbon representation, and it tells us that this is hydrogen suppressed. There are 3 hydrogens here on this carbon, 2 hydrogens on this carbon, 2 hydrogens on this carbon, and 3 hydrogens on this carbon. Hydrogen suppressed line structures are the way that I will refer to almost every compound from here on out in organic chemistry. It's easier to draw these, and it allows us to focus on different functional groups as we see them. Let's take, for example, C2H4. If we draw the 3-dimensional shape here, and I indicate the double bond present, I've had to draw all 4 hydrogens in and the 2 carbons. If I go to a hydrogen suppressed line structure, I'm going to simply draw a pair of parallel lines. The end of each parallel line is a carbon with 2 hydrogens attached to it. If I go from C2H4 to C2Cl4, I still have a double bond present, but now I have chlorines at the end of that carbon-carbon double bond. Unlike C2H4, when I draw the hydrogen suppressed line structure, I need to indicate the halogens. So I will draw those in like that. If we go up to propene, CH3CHCH2, I'll end up with a structure like this for my hydrogen suppressed line structure. CH3, CH, CH2. I don't need to indicate the double bond here, although sometimes I will draw that as CH3, CH double bond, CH2, just to help you along.